Hello class, this is Mr. Sutton, and today we're going to be talking about writing exponential functions and applications of exponential functions. So first thing we're going to talk about for exponential functions is the general form. So the general form is y equals a times b to the x power. It's called exponential function because x is in our exponent. And a couple things to note. A, in this case, is the initial value, and b is the growth or decay. You could also think about this as the multiplier, the number we are multiplying by each time. You could also write this in function notation with f of x equals a times b to the x power. And then another thing you'll need to note is that b, the b value, can sometimes be expressed as 1 plus or minus r. That is if you're given the r value, which is the rate. So sometimes they won't give you the b value, they'll give you the rate. And in that case, you'll have to take 1 plus or minus, depending on if it's growth or decay. If it's growth, you take 1 plus the rate that they give you. If it's decay, you take 1 minus the rate that they give you. All right, so those are some things to write down in your notes. All right, let's look at this example. A new car is purchased for $24,500. The value of the car depreciates at 14.75% per year. What will the value of the car be to the nearest cent after 14 years? So this is a rate. Percentage is always a rate, and it says it's depreciating at this rate, so that is decay. So a couple things to note from reading this. So we look at our general form, y equals a times b to the x power, but we want to use b equals 1 minus r because we're given the rates of 14.75%. So we can go ahead and calculate that b value. So that would be 1 minus 0.1475. We want to convert this percentage into a decimal, and then that is what we want to plug in to our generic formula here. So that would be 1 minus 0.1475, 0.8525, and then our a value is our initial value, which is 24,500. All right, so now we have our equation. Now we can go ahead and calculate what the value of the car will be to the nearest cent after 14 years. So the time will be on the x-axis. So we can go ahead, plug in 14 here. And then we just need to plug this into a calculator. So you want to make sure you do that right. So you take your 0.8525 and raise that to the 14th power. And then you take whatever that value is, that is 0.107083221, and you multiply that by this 24,500. So multiplied by 24,500. And you should get y equals 2,623 and rounded to the nearest cent. So that would be to the hundredths place. So that is 5.4. I have 538,922. So because of the 8, we round the 3 up to 4. And I'm going to use the approximately symbol here because we are rounding. So final answer, 2,623.54. Let's go ahead and look at this next example. $4,400 is placed into an account with an interest rate so notice it says right here, of 8.25%. How much will be in the account after 29 years to the nearest cent? So once again, we're going to start with our generic form. We know that the A value has to be the initial value, so that's 4,400. And then once again, our B value is given to us as a rate. And this time, the money is being placed into an account with interest. So that means the money that's being placed in an account is growing each year. That's why you put your money into a bank account, because it can grow because they apply interest to it. So that will be 1 plus the rate, which is 8.25%. So convert that to a decimal, and that is 0.0825. So that's equal to 1.0825 once we add those together. So now we can go ahead and plug these values in to our generic equation. And we have our formula for this account. So how much will be in the account after 29 years to the nearest cent? So once again, the time is going to be our x variable. So we want to go ahead and plug that in for x. So that is 29. And then now we just need to use our calculator to calculate this. So you want to first take this 1.0825 to the 29th power, which is 9.963433853. And then you take that value and multiply it by the 4,400. And I got y is approximately 43839 point, and then rounded to the nearest cent. So once again to the hundredths place, 13. And again, I use the approximately symbol because we're rounding here. So that is $43,839.13. So the account grew from 4,400 to 43,000 after 29 years. So that's quite a bit of growth. One thing to note is make sure you're rounding properly. If you put in 43,839.12, Delta Math is going to count that wrong, even though it's very close. And don't think that because you're rounding, it's okay to be off by a little bit, because it's not. Delta Math expects you to get this exact answer. So this answer is not okay. All right. So if you have questions about your rounding, make sure you are talking to me, asking for help, so we can figure that out. Now here we are writing an exponential function in the standard form, y equals a times b to the x power, and we want to make sure it goes through these 2 points. So in order to do that, basically what it's asking us to do is figure out the a and the b value. So in order to do that, we just have to plug in the points that we're given one at a time. We want to start with this point right here, because they give us this point where x equals 0. That actually gives us a lot of information. That's the initial point. That's very useful, because what happens when I plug these values in, I plug 6 in for y and 0 in for x. Because here we have b to the 0 power, and we know that anything to the 0 power equals 1, b to the 0 power equals 1, so a times 1 is also just a. Once we simplify this, we get 6 equals a. So now, all of a sudden, we know what a is. We know it's 6. So that gave us a lot of information. Now, there's two ways you can do it. You can do this the way I did, where you plug in the values and simplify it, and you get a equals 6. Or you can just know, because that this is on the y-axis, 0, 6, that means it has to be the initial value of our exponential graph, because that's the starting point, because x counts up from there. So that would be the starting point for our exponential graph. Then that just means that our initial value is 6. So you can think about it that way as well, but I also recommend make sure you do the math and make sure it makes sense. Now we can go ahead and find the b value, and we do this by using the other point. So we plug in 96 here for y. 96 is the y value. B value we don't know yet, and 2 is the x value. Now you can see we have an equation that just has one unknown, and that is b. So now we can solve this for b. So the way you do that, you got to be careful here, and you have to recognize that this square is only being applied to the b value. So the first thing we want to do is we want to try to get b by itself. So first we need to divide that 6 away, and 96 divided by 6 is 16. So then we have b squared equals 16. And then now we can square root both sides. The square root of 16 is plus or minus 4. Square root of b is b. Now, the thing is, b has to be positive. B cannot be negative. That's one thing to add to your notes. Reason for that is, if I take this negative 4b answer that we got, y equals 6, and then negative 4 to the x power, this can't be a function, and it's asking for an exponential function here. The reason why it can't be a function is if I say x is 1/2, for example, you can't take negative 4 to the 1/2 power. That's the same thing as the square root of negative 4. You can do that, but you'll get an imaginary number, and that means it's not a function. That is not a point that we can find on our graph, so this is not a function. So that's the case for any b value. B cannot be negative, so that means we can go ahead and throw out that negative answer and just say b equals 4. So that means our function is just this, y equals 6 times 4 to the x power. And one thing to note is delta math does want your answer in this form, y equals, not f of x equals. So I tried it, and if you do f of x equals, they will count it wrong. So make sure you put it in y equals form. So now here we have another one where we're given 2 points, f of 2 and f of 3. So those coordinates would be 2, 23, and 358. And we want to find the value of f of 6 to the nearest hundredth. So the way we want to do that is we want to, again, take our standard form, and we want to come up with an equation based off the information we're given. So we can take 23 equals a times b to the 2 power. And we can also, we got this 58 equals a times b to the 3rd power. So just plugging in these 2 points into our standard form, our general form. The thing is, neither of these have an exponent of 0. So neither of these will give us our a value like we did in the previous problem. But what we can do is we can divide these 2 equations by each other. I'm going to take this 58 equals a times b to the 3rd. I'm going to divide 23 equals a b to the second. 58 divided by 23 is this 2.521739130435. The a values cancel each other out. And then the b values, this becomes just b to the first power. Remember, we subtract the exponents. B to the third over b squared is b to the first power. So from this, we are able to find our b value. So now that we have this b value, we can go ahead and plug it into one of our equations up here. So 23 times a times this b value, 2.521739130435 squared. Now we have an equation that's just missing the a value, so we can go ahead and solve this for a. First thing you're going to do is take this number and square it. You want to be as accurate as possible. So make sure you're not rounding this off anywhere. And then I got 6.359168242. So you want to take 23 divided by that number. 23 divided by that. And so I got a equals 3.616825208. So now we want to find the value of f of 6 to the nearest hundredth. So now we know our a value and our b value. So a value multiplied by the b value, and we want to raise it to the 6th power now. We're plugging in 6 for x, so that is what we are trying to find. So I'm going to go ahead and raise this number to the 6th power. And I got 257.1585364. Now multiply that number by 3.616825208. And I got f of 6 is approximately 930 point, and I got 0974, but we're around to the nearest hundredth, so that 9 rounds up to a 1, so becomes, or 9 rounds up to a 10, excuse me, so it becomes 930.10. So you want to save your rounding until the very end. Don't round until then, because some rounding with the b value or the a value could change this slightly to the point where you get the wrong answer. So you want to save your rounding until the very end. All right. And then one more example here. A sample of a radioactive isotope had an initial mass of 600 milligrams in the year 2003 and decays exponentially over time. A measurement in the year 2007 found that the sample's mass had decayed to 350 milligrams. What would be the expected mass of the sample in the year 2011 to the nearest whole number? So we have our general form. We know the initial mass is 600, and we know that after 4 years, 2003 to 2007, decayed to 350. So that means X has to be 4 years, and Y has to be 350. The thing we don't know is the B value. So after 4 years, so they basically give us, in a sneaky way, this coordinate for 350. So we have 350 equals 600. Don't know the B value. That's okay, because we have everything else. So now we can go ahead and solve this for B. So first thing I want to do is divide by 600 on both sides. So 350 divided by 600 is, I'm going to leave this as a fraction, 7 over 12, b to the 4th. So then to get rid of that exponent, I raise both sides to the 1/4 power. So I have b equals 0.8739351333. So now what would be the expected mass of the sample in the year 2011 to the nearest whole number? So now we know the A value, 600, B value, 0.8739351333. And our X value, if we're starting at 2003 and going to 2011, that would be 8 years. So now we have all this. I'm going to figure out what comes out. So we take our B value and we raise it to the 8th power. And I got 0.340277779 and multiply that by 600. And I got Y is approximately, now rounding to the nearest whole number. So again, you want to save your rounding to the very end. And I got 204. 204.1, and so the 1 tells us to round down to 204. So that would be 204 milligrams. If you have any questions about any of this material, especially the rounding, but if you have any questions about any of this material, make sure that you ask for help during class, and have a good day.